Hi, I'm Anand from Earthing Oz, and today we're going to do a few experiments measuring the electrical voltage that's in our bodies in different environments, just to get a picture of really how much EMFs are affecting our body. It's something that you can't normally see or feel unless you're particularly sensitive, but with a simple multimeter today we're going to test the voltage in my body in different environments to see how it changes. I've been into health and nutrition and exercise for many years now, and I really value my health, and I do have concerns about being in highly electrified fields or near mobile phones, Wi-Fi and things like that, and the effect it's possibly having on my body. So I'm looking at the best ways I can find to minimize EMFs. So with the multimeter, I'm just going to turn it on to volts. It's a little V symbol there. You can do this experiment yourself at home. It's a very interesting one to see how many volts your body's taking on. If I click the mode button, I'm going to change it. You'll see it's on DC. I'm going to change it to AC because that's the current that our buildings and houses have. Now, it's got two wires coming out of it. It doesn't matter which you use, the black or the red. I've got one with a little alligator clip going onto this extension lead, which is then connecting into the ground via an earthing rod. So this is an earthing rod you can use to earth your products, your earthing products. It's exactly the same one. And what we're going to do is I'm going to grab the end of this to see what my voltage is. Now we're out in the back garden. We're not close to any major electrical fields, and my voltage is very low. It's 0.06, and that's even with rubberized shoes on. I've got some old sandals on with rubber heels, soles on them. And now I'm going to kick the sandals off just as an experiment to see if there's any difference. I'm personally not concerned about having a body voltage of 0.05 or 6. It's not too bad at all. So I kick my shoes off, it goes to 0.004. It's not really a big difference and not a big deal when you're out in nature. So this is really what the human body is meant to be at. It's meant to be at a very low voltage, very close to Earth. But what I'm concerned about is when I go inside or I'm standing near power lines, what's going to happen to the voltage in my body. So let's go and have a look at that. So now I've changed location. I'm out the front of my house and I'm standing under power lines. So is it possible for these power lines to, through induction, send electricity into my body? We're going to find out in a moment. So I've got my multimeter. I'm going to hold the end of it, and I'm at like 0.6. So my body has now got, instead of being 0.006, we're at 0.6. So that's a lot more electricity coming into my body simply by standing under these power lines. So if we look up at the power lines, we're going to see there's a transformer box. I'm standing almost directly underneath power lines, and my voltage is 0.6 as opposed to 0.006, so it's nearly 100 times more voltage in my body simply by standing here. Now, just to show you an example of being earthed, I've got my rubber-soled shoes on. I'm going to kick them off, and now look at my voltage. It's back down to 0.014 on bare feet. I put on my rubber-soled shoes, and now it's gone up to very close to 1 volt, 0.9 volts. I kick off my shoes again, back down to 0.009 volts this time. So that just shows you the effect, the difference between wearing rubber-soled shoes, which nearly all of us do, and being barefoot on the earth. Now I've got some concrete here too. Let's do an experiment with that. I'm going to stand on concrete. It goes up to 0.02, so I'm still being earthed quite a bit. I was almost at 1 volt in my rubber-soled shoes, but on concrete I'm being earthed quite nicely to 0.017. Not quite as good as the grass, but concrete is conductive, so walking barefoot on concrete will earth you. Over here we've got bitumen, road paving. This is synthetic, and technically it won't earth me. If you look here, my voltage has jumped up to 1.3 volts. It's actually higher than even being in rubber shoes. So I'm on bitumen, 1.3 volts. I'm on concrete. We go down to 0.02 volts. Now onto grass. 0.013. So now we've demonstrated being outside in different environments, being away from power lines, on the grass or in rubber shoes, the difference in the voltage in my body, being under power lines, on concrete, grass and on bitumen. So as you can see, the amount of voltage in our body changes dramatically depending on what we're standing on. Being in rubber shoes, we're insulated the whole time, so they're possibly a health hazard. In the old days we used to wear leather shoes, everything was leather soled. Leather is actually conductive, it's a natural product, it gets a bit of moisture in it, it conducts electricity. So more than ever before we're being insulated from the earth, for one, so we're not getting the negative ions coming up from the earth into our body, which has an antioxidant effect. And at the same time we're not able to discharge EMFs that are just in our environment from power lines and places like that. So what's the problem with that? Research is beginning to indicate that our cells, which are like little batteries, we've got trillions of cells in our bodies, each one is like a little battery with a small amount, we're talking millivolts, we're talking a very small amount of current in our body, is very sensitive to these external forces of man-made electricity. And it's looking like there may be links between things like leukemia, brain tumours, and also the production of melatonin, which affects our sleep, is being interfered with by EMFs. So personally, I'm wanting to keep my voltage as low as possible for as long as possible. And this is what this video is about. It's about first measuring the voltage in our body and then finding ways that we can lower it. So now we're going to go inside and see what sort of EMF fields we're going to find inside the house. So now we've come into my office and I want to measure what the voltage is in my body while I'm sitting at my desk. So I've got my multimeter again. We've got it set to AC on the volts. This end I grab hold of. The other end now, because we're not outside, to earth it, I've got it going through, we've got this US adapter. This is a splitter plug which goes into the earth. You don't need this turned on, by the way. This just goes directly into the earth in our power point. Got that connected there. And now if we come back, I'm going to grab this electrode and we'll see what my voltage is. We're at 0.6 of a volt at the moment. Actually, we're at about 0.8 of a volt. I'm barefoot at the moment and it's well over 100 times more voltage than what I had in the back garden when I was out of EMF field. So we're talking 100 times more voltage in my body sitting at my desk. So obviously I can't go barefoot and earth myself unless I'm on a concrete floor. I've got a synthetic carpet. I will get a little bit of grounding through that. Let's just I'm going to move my feet off this plastic here, which is totally insulating me, onto the carpet, and let's just see what that does to my voltage. There is concrete underneath this. We get a slight drop. It goes down to 0.5 of a volt, half a volt, back onto the plastic, up to 0.7. So it's a minimal amount of earthing happens when I put my feet onto this synthetic carpet, which is just sitting directly on top of concrete. Okay, it's still way too high for my liking. So what can we do?